Okay guys, here's another problem. This has to do with projectile motion, and it's kind of like the one we've been doing so far. Okay, so here's the question. It says, a ball with an initial velocity of 7 meters per second rolls off a table measuring 2 meters from the ground. How far away from the base of the table does the ball hit? Okay, so let's take a look here. What we have here is we have a ball sitting at a table, right? And it's going to fall in this direction, right? It's projectile motion. We need to know exactly how far away from the base of the table it hits. So we're looking for this right here, which is the delta x, right? Okay, now we know our delta y. Our delta y in this case is equal to 3 meters off the 2 meters, 2 meters off the ground, right? Okay, so we've been talking about this earlier. We have two equations that we can use, right? We know that delta x is equal to the initial velocity times time, and we know that delta y is equal to 1/2 gt squared, right? Okay, so let's take a look and see what's going on here. If we need to figure out what delta x is, we need to know, we have the initial velocity, right? And we need to know time. So in order for us to figure out time, then we need to use this equation right here. All right, so let's take a look. We're solving for time, right? So delta y is equal to 1/2 gt squared. I'm going to multiply both sides by 2, and I'm going to get 2 delta y is equal to gt squared. Divide both sides by g, and t squared is equal to, let's see, 2 delta y all over g. Now, of course, I'm looking for t, not t squared, so t is going to give me the square root of 2 delta y all over g, right? Okay, so what I'm going to do here is I'm going to go ahead and just shrink this down a little bit. All right, and I'm going to move it off to the side so I can keep working. All right, now back to where we were. I know that delta t is equal to the square root of 2 delta y over g. All right, so what I'm going to do then is I'm going to plug everything in. Time is equal to the square root of 2 times 2 meters all over negative 9.81 meters per second squared, right? All right, in this case it's going to be the square root then of 4 meters divided by negative 9.81 meters per second squared. Now keep in mind that this ball is falling in this direction, so because it's falling, my distance is going to be negative, right? All right, so okay, so once I take these two numbers here and I divide them, I should end up with the square root of 0.4, sorry, let's see, 0.407, and this is going to be seconds squared, right? Because meters here cancel. All right, once I take the square root, then I should end up with 0.638 seconds. So then time is equal to 0.638 seconds, right? Okay, so look, all I did now was just find my time, right? Now, I use time. Time has to be done in the y-axis. Remember, these two motions are independent of one another, so you have to take one at a time. So now that I've calculated time, then I can go into my x-axis and say, okay, well, if I want to figure out the distance, then all I have to do then is multiply my initial velocity times time. So in this case, it's going to be 7 meters per second, and I'm going to multiply that by my time that I just calculated here by 0.638 seconds, right? Seconds cancel, and we end up with, delta x is equal to 4.46 meters, right? Since seconds canceled right here. Okay, so if a ball rolls off the edge of a table with an initial velocity of 7 meters per second, right, off a table that's measures a distance of 2 meters, right? Then the ball will land 4.46 meters away from the base of the table, which is equal to my delta x. All right, so what did we do here? All we did was, well, let me see if I can move this here. Give me more space to work. There we go. All right. All we did then was we solved for time in the y-axis. Okay. Then we took this time and then we applied it to motion in the x-axis. By doing this, we were able to find delta x, right? Because we know that delta x is just equal to the initial velocity on the x-axis times whatever time it takes to fall, right? So there it is. All right, this is just an example, and I'll see if I can put up a few more. All right, later, guys.